Hello everybody, how you doing? This is Mr. Dowse. This is going to be me going over some sporadic problems for the Pythagorean Theorem, special right triangle, and geometric mean tests that you're going to be taking later this week. I'm not going to solve every problem, but I'm going to solve like one type of problem for each kind of random situation that we've come across in this in the last week or so of lessons. And I'm just going to kind of jump into this and solve this. So if I look at number one, first it says find the length of the missing side in the following examples. Round answers to the nearest hundredth or 2 decimal places if necessary, and then show all work. So I'm going to solve a problem like number one and a problem, let's say, like number 6. So if I look at number one, on number one, this is a Pythagorean Theorem problem because I have a right triangle and I know 2 out of 3 sides. And my goal here is to find the third side. So this is a dead giveaway. It's a Pythagorean Theorem problem. So I'm going to write down the Pythagorean Theorem. And so keep in mind here that opposite the 90 is always going to be side C. It's always the hypotenuse. So in this particular case, I'm solving for C, and so I'm just going to label these other sides here as A and B. Again, I can make this guy B and this guy A. It doesn't matter, but these cannot be C. So if I plug in 6 for A, 3 for B, and I'm solving for C, if I do the math here, this is 36 plus 9 equals C squared, 45 equals C squared, and my answer is not 45, it's the square root of 45. So if I take a calculator, which I have in front of me, sorry, didn't know where I put that. So if I have a calculator and I type in, let me fix this as well so we don't get a glare. So we have the square root of 45. Our answer is going to be 6.71. So the problem says to round it to 2 decimal places. So this guy becomes 6.71. So 6.71 is your answer. And the idea is, just to check your answer real fast, C is the longest side. So notice that 6 and 3 are the smaller 2 sides here. This number is greater than either one of those, so this is probably the right answer. Just kind of a little quick check. If you did the math here and it was smaller than either one of these, then you know you did the math wrong. And so now I'm going to jump to number 6 here. I'm solving number 6 right here because 6 is where you're not given C. Or sorry, you are given C, and you're solving for either A or B. So in this case, the 8.6 is C. So I'm solving for either A or B here. So in this case, let's say I'm solving for A, and my B is 2.7, and my C is 8.6. So in the equation, A squared plus B squared equals C squared, I'm going to plug in, I'm just going to leave A as A squared. I'm not going to put X in there. My B is 2.7 squared, and this equals 8.6 squared. So notice I'm given C here. So I'm not going to end up adding these two and square rooting it to get my answer. There's going to be some kind of subtraction happening here. So if I take my calculator and I do 2.7 squared, so I have A squared plus 7.29 equals 8.6 squared, 73.96. And so to get A squared by itself, I need to subtract by 7.29 on both sides. So my A squared is going to equal this guy minus this guy, and that's 66.67. And if I want to find A, I square root both of these, and I get an answer of roughly 8.17. So again, I'm rounding this to 2 decimal places, so this is 0.165. This 5 rounds this up to 7, so I have 8.17 is my answer on number 6. And so the idea is I solved these 2 problems out of these 9 because in one of these we're solving for C and in one of these we're not solving for C. So notice on number 2 and on number 3, we don't know what C is because this is the longest side. And so the idea is 1, 2, and 3 are all going to be solved the same way where we're going to be adding. And if I look at 4, notice we're given C. This is C. 5 we're given C. 6 we're given C. 7 we're given C. 8 we're given C. 9 we're given C. So problem 4 through 6 are going to be solved the same way where you're going to end up subtracting whenever you do the Pythagorean Theorem. So keep that in mind. So if you're finding C, you're going to end up adding A and B. If you're given C, you're going to end up subtracting at some point, and you're going to get your answer for either A or B. And notice here, 8.17 is smaller than the hypotenuse here, so this is likely the right answer here. So again, you always want A and B to be smaller than your hypotenuse. So let's look at number 10. 10's a good question, and I don't think I did one of these in my class just because we didn't have the time to do it. So that's why I'm going to do this right now. So to get from point A to point B, so this is point A and this is point B, you must avoid walking through a pond. To avoid the pond, you must walk 34 meters south and 41 meters east. To the nearest meter, how many meters would be saved if it were possible to walk through the pond? So notice here, our goal is to solve for C. That's the first goal, and then the second goal is to find the difference between the distance that you did walk versus if you could walk through the pond here. Yeah, so let's say here, so A squared plus B squared equals C squared. And if I look here, this is going to be A and this is B, or vice versa. The ultimate idea here is this guy here is C. We don't know what C is. So I need to plug in these numbers in for A and B. And I'm going to do a little trick here. I'm just going to plug 34 squared plus 41 squared in my calculator. And that gets me 2,837 equals C squared. And now I'm going to square root this to get my C value. And I get my C value to be 53.26 meters. Again, so this is saying, round to the hundredth places. So I'm going to do the same thing on number 10. I don't think it means for this problem, but I'm going to do it anyways. So the distance from A to B is roughly 53.26 meters. This is not the answer. This is just part one of the problem. Part two is, which is going to get me the answer, is we need to find the difference between the distance that was walked, the 34 meters plus 41 meters, compared to if you could just walk straight from A to B. So if I were to add A plus B, that's 34 plus 41, you get 75 meters. Versus part two here, versus C is 53.26 meters. So if I subtract these two values, whatever I get here is going to be my answer. So I'm going to subtract 75 minus 53.26, and I get 21.74. I did that wrong. 0.74 meters. But notice the question says to the nearest meter. So 21.74 rounds up to 22 meters. So anyways, the answer is 22 meters here. So the idea is we needed to find C, and then once you know what C was, we had to find the difference between what A and B was and C to get our answer. And since it said to the nearest meter, we had to round up. On my test, if you gave me 21.74, I would take off a point because you didn't round it to the nearest meter. So make sure you're going to do that, all right? And so let's look at a couple more problems here. I think I'm only going to do the Pythagorean Theorem problems on this one, then I'll move on to another video for special right triangle and another one for geometric mean. But let's look at number 12. Number 12 is another word problem. So first of all, this needs to say helicopter. So the idea is we have a helicopter rose vertically 425 meters. And then it flew west 650 meters. How far is a helicopter from its starting point? So where we started right here is my starting point. And the helicopter ended up over here. So the goal is we want to find what this distance is. So again, so just to simplify this a little bit, I'm going to say north is up, south is down, west is to the left, and east is to the right here. So when I go up, rose vertically, let's say it's kind of like a north in my mind. And then I'm going to go west. So that's how I kind of drew this picture here. So this is another Pythagorean Theorem problem. And notice how we have a right angle where this goes up and then takes a left. So this is a right angle. So in this problem, we're actually solving for C. So I'm going to make my, my 650 my A value, my 425 my B value, and I'm solving for C. So I'm going to do this quickly in the calculator here. So let's do, what, 650 squared plus 425 squared. And I get this number 603,125 equals C squared. going to square root this, and that's going to give me my C value. And roughly 776 point, let's say 6. It doesn't say what to round it to, so I'm just going to go to the nearest tenth. So this is 776.6 meters, and that is my answer on number 12. Just hopefully that makes sense here. So let me do a couple problems on 13 through 18, and then I'll stop this video, and then I'll do another video for the other kinds of problems. So determine if the following side lengths can form a triangle, and if so, is the triangle acute, obtuse, or right? So first of all, we did this in the notes, like on Pythagorean Theorem. Is it a triangle? If it's a triangle, A plus B needs to be greater than C. If this is the case, then yes, we can make a triangle. Can make triangle. And then once you know if it can make a triangle, we need to know, is it a right triangle, an obtuse triangle, or an acute triangle? And the way to tell that is if your A squared plus your B squared equals your C squared, then this is a right triangle. If your A squared plus B squared is less than your C squared, or your C squared is greater than your A squared and your B squared, then we have an obtuse triangle. And then on the opposite end, A squared plus B squared, if that's greater than your C squared, then we have an acute triangle. So the idea is we need to do two things here. I need to see, do these sides measure up to even create a triangle? And if so, what kind of triangle is it? So let me do number 13. I'll do 14. Actually, let's do 13, 16, and I'll do 17. And then I'm going to call it quits in this video. So notice your A and your B values are always going to be the smallest two numbers. So my 7 is my A, the 12 is my B, and my C is my 16. Again, C is the largest number. These could be A or B. It doesn't matter. I can switch these around if I want to. But I'm going to plug, so I'm going to do 7 plus 12. Is that greater than my C value of 16? I'm testing right now. This is a triangle. And I get 19. Is 19 greater than 16? The answer is yes. So this can create a triangle. So since this is true, I can now do Pythagorean theorem here. So I'm going to say 7 squared plus 12 squared, is that equal to 16 squared? And I'm just going to kind of fast forward here and do this a little quicker. 49, so I'm just going to, so I don't make this video too long. So the left side becomes 193, and the right side is 256. So since these aren't equal, this is not a right triangle. But since my right side, my C values are greater than my A and my B combined, this ends up being an obtuse triangle. So the answer here is it's an obtuse triangle. If I look at 16, I'm doing this one because this one's a little sneaky. Notice your C value here is the guy in the middle. So these are out of order on purpose to try and trick you. Notice your A and your B values need to be your smaller two values. So if I take 3 plus 5, is that greater than 7? Is 8 greater than 7? The answer is yes, so yes, this is a triangle. Now that I know this is a triangle, is it a right triangle, obtuse triangle, or an acute triangle? So let's do 3 squared plus 5 squared. Is that is that equal to 7 squared? That's 9 and 25 becomes 40. Oops, I messed up. So let's say 9 and 25 is 34. Is that equal to 49? The answer is no. And this is another example where the right side is bigger than the left side, so this is obtuse. So I was hoping I wouldn't do two triangles that were the same, but the idea is that since the right side is bigger than the left side in this case, your C squared is bigger than your A squared. This is an obtuse triangle. Yeah, and so if these were equal, this would be a right triangle. If your left side was greater than your right side, this would have been an acute triangle. But I'm not going to do those other problems. So 17, let's look at 17. Your smaller two values are your A and your B, and your largest is your C. So if I do 5 plus 8, is that greater than 13? The answer is no. These are equal to each other. Guys, if they're equal to each other, it does not make a triangle. So your A and your B, this has to be bigger than your C value. So since these are equal and they're not, this side's not bigger than this one, you cannot make a triangle. And that is the answer to 17. So I'm going to end this video on this note, and then I'm going to make a second one over special right triangles, and then a third one on geometric mean. So hopefully this is helpful on the Pythagorean theorem problems.